Good morning, everybody. So today I have a logic board repair that I thought would be good to do a video on. It's an issue with the board number is 820-00239. This is a late 2016 touch bar. I believe it's touch bar. Let me make sure. Yeah, it is a touch bar. Yes, it's a touch bar. It has the touch bar at the top here. The issue with it is the customer said coffee was spilled into the computer in the area of the power button and the delete key, which you know is the top right of the keyboard. The unit worked fine for the rest of the day, but won't start now. There's a couple issues. If you have liquid damage, if you accidentally pour liquid into your machine and by a miracle it continues to work, the best thing to do is to turn it off and go to someone who can disconnect the battery for you if you're not able to do that, and have someone clean the board. Because if liquid damage, if any type of liquid sits on the board and it's continuing to get power, electricity through the board, it is going to corrode eventually. Even if it doesn't do it right away, eventually it will corrode. It's just the way it works. So if you're like, hey, it still works, it's best just to turn it off, remove the power from it, find someone quickly to remove the battery to get the power out of the board. That way they can clean the board. In that case, it may only need a cleaning and it's more likely to be fixed. But if you continue to let it sit and you continue to run the machine with liquid in the machine, it will corrode. And eventually you could damage it to the point where it's not repairable. So anyways, this board is no longer powering on. And the reason why, I will show you. I'm going to take the USB-C port here, plug it into the board, and take my USB-C multimeter, amp meter, and I'm going to plug it into the board. Alright, let me see if I can get you to see this. Get this in place. Alright, you see there it has 5.11 volts and 0.03 amps. The problem with this is the 5.12 or 13, 14, whatever it is, volts. It's supposed to get 20 volts. Like usually it's 19.8, 19.9 volts. This is not. So the problem is, remember we've done a video on this before, the MUX chip, the USB-C MUX chip or controller chip, is going to be liquid damaged. In this case, I've already looked over the board and I found that, you know, on the right side of the board where the liquid damage or the liquid entered the machine, there is some damage around these chips. Now, hopefully, fingers crossed, that the chips themselves aren't bad, because we already know those aren't fun. It's a BGA chip. You have to remove it. You have to find another one from another board. You have to reball it. Then you have to put it on. Hope that the chip that you removed from another board is good. That way you can get a working board. So the process of doing that is no fun, and it's not guaranteed to work the first time, so you may have to do it several times, which could take most of your day. However, I'm going to show you under the microscope in hopes that this board, let's see, I believe it's this board right here. I've actually been holding the wrong board in my hand. It's the same board, but this is the customer's board. I'm going to show you under the microscope the issue we're dealing with. There we go. Alright, so looking here under the microscope, I'll get you a view. Not that you're going to be able to see anything. Get you in focus. You can see this is the USB-C controller chip. This chip here. This is the chip we hope we don't have to replace. But you can see the components around it are liquid damaged. And this could be causing the chip not to work. Also down here, we have some more liquid damage around these capacitors. So hopefully by removing this capacitor here and clean the board, maybe removing a couple other components and replacing those, maybe we can get this in working condition without replacing the controller chip. So we're going to go ahead and try that. I'm going to remove this film from, I believe this is the storage for this board. My tweezers have seen better days, obviously. Add a little heat to it. It seems to come off when it's a little bit heated up. Yeah, much better. Okay. Alright, so we set that to the side. And so, looks good underneath there. Now this is actually a SanDisk storage. So, we might have to replace a few of these other components. Maybe not. We'll try just cleaning them. But the main one I'm concerned about is right here. So what I'm going to do is heat up the board enough to remove this shield around the chip. Not much. I'm not going to heat it up too much. It doesn't take too much heat to remove these. And it's a low melt solder holding these shields on. And that was something sugary that they spilled because it smells really sweet smelling. Alright, so I'm going to go ahead and what I'm going to do, I'm going to show you how I can test this capacitor. Test it to see if it's shorted out. And you've seen it before, but we're going to test this. Put it on resistance mode, or diode mode. Better view for you. Okay. And as you know, when we touch one side to ground and one side of the capacitor, that reads short to ground. How does this side read? Short to ground, or it's ground. So this capacitor is probably bad. Either that or this controller chip is bad. So what we're going to do is we're going to remove this capacitor and check the pads after we remove it. Heat it up just a little bit. Just like a little bit, just break it off like that. Now let's check those pads and see if we get a different reading now that the capacitor is off. Now that is ground. And this side, we're no longer short of the ground. So you can see that that capacitor was what was bad, causing the direct short to ground. So we're going to replace that capacitor. We're going to put a new capacitor on. And here's when I ran into another issue when I was looking at this. But I'm going to go ahead and get the pads ready while I have it in the microscope view. Add a little bit of flux. And then a little bit of solder. Put some fresh solder on those pads. Okay. Alright. So, you know, we usually get these extra capacitors and things from donor boards. Alright? Let me show you my donor board. So this same exact pad, or the same exact capacitor on my donor board, also looks like junk because it is liquid damaged. This one right here, and I don't trust that. I mean, it may be a good capacitor, but I don't trust it. It just doesn't look good. And I would feel bad to put that on a customer's board. So what do we do in situations like this? Well, we're going to look at the schematics in the board view, and as you know, these have multiple of these USB-C controller chips on the board. And if you have multiple of these, you should have the same components controlling, or like capacitors and resistors, around each of those controller chips. So we're going to look at another chip. Let me show you real quick under the microscope. Here's another one on the other side of the board, and these capacitors look great, actually. And you can see this water or the liquid sensor that turns red when it gets liquid damaged. It's still white, so this area of the board has not been liquid damaged. So these capacitors are probably going to be the same ones that are used for the other chip on the other side of the board, so we can probably pull one of these. I'm not sure which one, so what I'm going to do is show you on the board view and schematics how we can find out which capacitor we need. So let's take a look at the board view. Let's see. So here's our board, and here is the chip we were looking at. This is the one that's liquid damaged on our board, and here is the capacitor on our board that we need. This is the one that we removed, and we've already, tinned the pads and gotten that ready. So the component part is CB308. Now let's jump over to our schematics. Alright, and I'm on camera now. So there we go. Here is our controller chip, USB-C controller chip, and CB308 is right here. This is the resistor, or the capacitor I mean, that we are looking for. So here is all the specs of that capacitor. So it's 10 farads, and it's got a 20% variance range, 6.3 volts, and it's a ceramic type X5R, and the size of the chip is 0402-1. So now what we're going to do is we're going to jump back to our board view, and we are going to look at the opposite side of the board where we were looking at under our microscope, and here's the chip right here, U3200. So this, we're looking at the C3208 and the C3200 as the ones that we could use. So now let's look back over at the schematics and see if this matches the specs we need. Now looking back at our schematics, just again before we jump over, here's all the specs of this chip that we need. So now let's look over at C3208 and see if we have a match. C3208, and looky there, it's the exact same specs that we have from that CB308. So this is the component that we can use in place of the one we just removed. So looking back at our board view, it's this chip right here, and let me see if I can get the view with our microscope. Which one is it? Oh, this one. Okay. So let me get you a better view in here. This is the capacitor that we're trying to get, and so here is the board removing it from. Okay, so you can see there. So it's this capacitor right here that we're going to remove, and we're going to use that capacitor in place of our other one. So we're going to go ahead and remove that and switch it over to our customer's board. Okay. Back over here. add this and put this onto the board. Okay. Now what we're going to do is clean up all the extra grime and stuff that we have on this board and see if we can get this looking a lot better. Now, as you know, you've probably seen me use this before. This stuff right here, this anti-static electronic equipment cleaner, works wonders at getting off corrosion on boards. And what I do, zoom back in on the board here. So here's the area that we're cleaning, and I'm just going to spray this on that area, and you'll start to see some browning of this foam, and that is the junk being removed from the board. See how the foam is turning brown right there? And that's because it's removing that really nasty liquid junk, whatever was spilled on the board. You can see right there it's turning brown as well. And so I like to spray that on there, use a toothbrush, and just gently scrub the area. And it does really well at getting off all this corrosion and extra sludge from the board. Alright, now let's turn it over and look at this side. I'm going to go ahead and clean this area up too. I don't see really anything bad, but since that liquid sensor has been tripped, it's good just to go ahead and make sure, clean up the area, even though I think most of the damage was done to the other side of the board. So I'm going to go ahead and remove that sensor. No sense in having it on there anymore, as it has done its job. And it is now done. Okay, now I'm going to go over to my ultrasonic cleaner and give this a real quick cleaning, and we will test it out again with the USB-C and the amp meter and see if we get 20 volts going through it, as well as some amperage. So I'll be right back. Okay, I'm back, and just looking this over, I cleaned off some corrosion. See, we were working on this chip right here. Down here below there is a little I think this is a capacitor, but it looks like one side of the capacitor is no longer attached. See how I can do that? So this side is completely corroded off. So I'm going to remove that, and we're going to replace that piece too. Alright, use my liquid acidic flux here. Put some new solder on those pads. As you see, the one on the right looks to be completely corroded. And look, it wasn't accepting solder, a holding solder on it, so now, with that flux, it's able to put some solder on those pads. And let's get our donor board and see if we have a good right there, which we do. It looks to be in good shape. So I'm going to remove that. Okay. Add this onto the board. Like that. Alright, now I'm going to be right back. I'm going to clean this off again, and then we can give it a test. Alright, so we're back. Let's take a look at it under the microscope. As you can see, it looks 100 times better. It looks so much more clean. I don't see any more corrosion around the area. The chips look like they're in good shape. The other side of the board as well looks to be good. I don't see any more corrosion or anything around. So let's give it a check. Let's put in our USB-C meter or amp meter. Get this full screen for you. Like that. Alright, and we're going to plug in our meter. And let's watch it together. There we go. 19.8 volts and 0.78 amps going up, which is good. It's showing that the board is powering on, and I feel the CPU getting a little warm, so it's getting power. So we didn't have to change the USB-C controller chip. Thank goodness. That was much easier, just replacing that. So you also got to see how if you don't have an actual component on the exact same area of the board on our donor board that was in good shape, or if you're missing that piece already, because I'm kind of limited on these donor boards. We don't have too many of these laying around, so unfortunately I didn't have that exact same spot to pull the chip from, or the capacitor from. So you saw how I looked at the stats of that chip, was able to find another one in the same or another location on the board, use that one, works just as well because it's the same chip. So anyways, we got this one up and running. I'm going to add that, here it is. Add the, put the solder disc back on so I can cover that SanDisk chip back up, and put this back in the machine and test it out. But everything's working now, according to what the amperage meter showed. So we're good to go. So anyways, I hope you enjoyed this. Hope you learned something. We made this job a lot easier than it could have been. So thankfully everything worked out. So anyways, I hope you have a great day. If you enjoyed it, have any questions, make sure leave us a comment so that we can get back with you and answer any questions you have. And also check out our website. See if it answers any of your other questions. If you need parts, or if you're looking for service or anything like that, give PowerWhat Medic a little look, and we'll be glad to help you out. Alright, hope you have a great day.